Okay, for this lesson, we're going to start by just looking at a few graphs that I want you to copy down. And then for each graph, I want you to consider, is the slope increasing or is the slope decreasing? And this is going to be a quick lesson. So we're just going to review concavity and how to determine concavity and work with it. So we're going to start with this graph. You should copy it down. And as you copy it down, make sure you also include these points here. You don't have to have these colors, just make sure that you label these points. And then what I want you to recognize is what's going on with the slope here, right? Well, the slope is negative. Okay, it's still negative, but what is the slope approaching? But it's approaching a slope of 0, which happens right here, right? Slope of 0. And then now the slope is positive. And then now the slope is positive and bigger. It's increasing and increasing. So when you think about a number line, if here's our slope of 0, and we're trying to put our slope on our number line, where is it moving? Well, it starts as being negative and bigger, so it starts over here. And then from here, it's negative still, but it's approaching a slope of 0. And then once we hit here, now our slope is still increasing and becoming more and more positive, right? So this whole time, the slope is increasing, right? So we can say that the whole time, f prime is increasing, which would imply that f double prime is positive the whole time. And we can see that in the graph because the graph is concave up. This is a concave up graph. Okay, so let's look at a concave down graph. This graph is concave down, and we want to do the same thing. We want to look at what's happening to the slope over time. Okay, slope is positive and big at the beginning, right? Because it's a steep function that is increasing. And at the green points, it's still, slope's still positive, but approaching 0, right? Because the slope is 0 right here. And now it's negative, and now negative and more steep. So let's think about our number line. If we're looking at the slope on a number line, it starts as being big and positive, so it would start over here. Okay, but then from here it approaches a slope of 0, which happens at this purple point up here. And then now it's negative, but it's negative and becoming more steep, which means we're going to keep moving further to the left on the number line, which means that whole time, if this is our representing our f prime is decreasing, which implies that f double prime, the slope of f prime, is negative. And we know that when f double prime is negative, that tells me that the original function is concave down, and that's what is going on with this function here. Okay, now look here, this function starts as being concave down and then moves to being concave up, right? So let's think about our slope. Okay, in this bottom section, our slope is positive and big, right? But approaching 0, which again on a number line, if this is 0, would mean we'd start over here and move this way. So f prime is decreasing, which implies f double prime is negative, which implies the function's concave down. But then when we move up to this section, we see the slope is 0, but getting larger, right? The function is becoming more steep. So now on our number line, we have our slope of 0, and what's happening to our slope is it's moving this way. It's positive and becoming bigger, which would imply that f prime is increasing. Oh my gosh, this is turning into a little bit of a mess here. Sorry about that. Is increasing, which implies that f double prime is positive, which means that our function should be concave up, right? So it switches from being concave down to being concave up. Okay, another one that starts as being concave down and switches to concave up, and we don't have to do the whole table again this time. Let's just look at this. The function is increasing, but it's approaching a slope of 0. So then that would mean that f prime is decreasing. Okay, which means f double prime is negative and we're concave down. Okay, now the slope is still decreasing, it's negative, it's becoming more steep, but then what happens is now we're going to eventually reach a point where we start approaching a slope of 0 again, meaning that we're going from a negative to 0, which means our slope is now increasing, and then it keeps increasing as the function becomes more steep. So in this section, f prime is increasing and f double prime is positive, making the concave up function. And we can kind of almost see exactly where the POI happens. It might be like right there. That's where the concavity switches from negative to positive, concave down to concave up. So we can actually look at this in terms of f prime and f double prime graphs. So if we look at f prime, okay, we notice that the function is concave down the whole time that f prime is decreasing. So if we like draw a line right here, that'll show us exactly where the POI happens, right? Because that's where f prime starts increasing again, which means the function is going to be concave up, right? And then the other thing we can notice is that we have our maximum right here where f prime goes positive to negative, and our minimum right here where f prime goes negative to positive, right? Corresponds with the maximum of f and the minimum of f. And then when f prime itself is at a minimum, that's where f prime has gone from decreasing to increasing, which means f double prime is going to go from negative to positive, concave down to concave up. Okay, so let's look at f double prime now. Okay, again, we can see the point of inflection happens exactly where f prime is 0, POI. Okay, and whenever f double prime is negative, the function's concave down. And whenever f double prime is positive, the function's concave up. So that's what this is showing. Okay, it's showing concave down here, concave up here, point of inflection at the x-intercept. Okay, we're going to do one example where we determine our POIs and we make a table to talk about the concavity. So we should zoom in on this function. The function itself is x to the fourth plus 4x cubed minus 18x squared. If we're going to talk about concavity, we have to find double prime. So first we'll find g prime using our power rule, 4x cubed plus 12x squared minus 36x. So now let's find g double prime. Okay, this is going to be 12x squared by the power rule plus 24x minus 36. Okay, now we should try to factor this to determine when it's going to be 0. So factor out the 12 first, 12 times x squared plus 2x minus 3, and then factor that quadratic, so we get 12 times x, we'll say plus 3 times x minus 1. So our POIs happen at x equals negative 3 and x equals 1. So now let's talk about the concavity here. So we'll go from negative infinity until our first POI at negative 3, and then we'll go negative 3 to 1, and then 1 to infinity. And let's talk about what's going on with f double prime, and then we'll use that to describe the behavior of f of x. Okay, so let's think about g double prime. G double prime is a quadratic function, and its end behavior is going to be up, up, which means it must start positive and it must end positive. So we know that f double prime starts as being positive because it's a quadratic. It must switch negative and then switch back positive. So what that tells me is that the function is concave up from negative infinity to negative 3, concave down from negative 3 to 1, and then concave up from 1 to infinity. So the function probably looks something like this. Okay, it's a degree 4 polynomial, so it starts concave up, switches concave down, and then switches back to concave up, right? This is a good guess for what f of x looks like, right? It's a degree 4 polynomial, so it's got to have end behavior up, up, and what g double prime tells us is how the concavity changes, which must mean we have this middle section where it comes back up and is concave down for a second. Okay, last thing. Your closure is going to be to copy down a couple tables here, so I'm just going to do these tables, copy them down with me, take a picture to show me you did it, and submit it on Classroom. So, first table, f prime x, f of x. Okay, if f prime x is positive, that implies f of x is increasing. If f prime x is negative, that implies f of x is decreasing. And then if f prime x is 0, that's going to tell me that I'm at a max, min, or shoulder. So graphically it'll look like this, or like that. Okay? Now let's do f double prime. If f double prime is positive, that implies f of x is concave up. If f double prime is negative, that implies f of x is concave down. If f double prime is 0, okay, that could mean that we're at a point of inflection. Okay, I'll specify one thing about that in a second. Okay, it's a POI. Okay, the important thing here though is that there has to be a sign change that occurs. So it's not enough for it to be 0. It has to either go from negative to 0 to positive, or positive to 0 to negative. And that's an issue that won't really come up till next year. For now, it's just important for you to know that point of inflections occur when f double prime is equal to 0, when it's positive, concave up, when it's negative, concave down. Okay, now last we're just going to make one more table where we combine these. So make sure you have these copied down first. Go back and rewind if you need to. Okay, for this last one, we're going to do f prime, f double prime, and f. So let's consider f prime positive, f double prime positive. That means the function is increasing in concave up, so it would look like this. What if f prime is positive but f double prime is negative? That would imply the function is increasing but concave down, so the function would have to look like this. Okay, now we can make f prime negative and f double prime positive, so now the function is decreasing but it's concave up. So how can I make a function that's decreasing and concave up? That's going to look like this. And then lastly, they can both be negative, which means the function is decreasing and concave down. So we needed it to be decreasing and concave down, all right? And then like maybe you could come over here and say this is representing slope and this is representing concavity. Okay. And those are our 4 different options for a function. A function could be increasing and concave up, increasing concave down, decreasing concave up, or decreasing concave down.